Hello. Before we start, two things. Firstly, I'm gonna be drawing with a mouse. I don't have a stylus, and this is due to budget cuts for the video that have had to be made. So you're not gonna be able to read half of what I write. Secondly, we're using Microsoft Paint because I can't afford anything else. Once again, due to unpredicted budget cuts for this video. Okay, so the problem says that we have a rectangle with side lengths 1 and 3. It's right here. Can you see the mouse? Yes, you can. Okay. The square has side lengths 1. It's right here. And we have a rectangle here. And it's all inside a really big square. That's all the problem says. So there are two things that really stand out initially. So the first thing is that we have a lot of similar triangles here. So if you look here, like we have a similar triangle here. I'm going to highlight all the similar triangles in green. During the contest, these are just intuitively similar, and if you're looking at this after the contest, you can try showing that these triangles are all similar. It's not that difficult. You just use a lot of angles. Some of these triangles are also congruent, so that's really helpful. So we're just going to draw these in. These are all the similar triangles we have. With this, it's going to be important because we have a square, too. That's the second big thing. We have a square. And squares have equal side lengths. So this big square, this is equal to this. This is a really good bracket. Yeah, I know what. Yeah, that's beautiful. Okay, so we're gonna have an equation. So we're gonna let this be A. This little thing here, from here to here, this is gonna be A. And by congruence, once again, you can show this later, but this is just really simple stuff. So this is A. This is gonna be A. This is gonna be 3A. That's cool. That's gonna be A again. And then by Pythagorean theorem, this is going to be square root of 1 minus a squared. So is this, 1 minus a squared. And then this is going to be 3 times 1 minus a squared, extra special. Okay. And now we can write an equation in terms of the two side lengths of the square. We have two ways of finding the side length of the big square. So we have a add 2 root 1 minus a squared add 3a is equal to a add 3 times square root of 1 minus a squared. Once again, half of this probably isn't legible, so that sucks. And we can manipulate this equation to get 3a is equal to square root of 1 minus a squared. We can square each side because, well, we don't like the square root. So we have 9a squared is equal to 1 minus a squared. And finally, we have a squared is 10. Oh, wait, no. A squared is 1 over 10. I'm really good at this. And then a is 1 over root 10. So that's really important. So we have, like, a lot of good stuff now. We know a lot of stuff. So, like, yeah. So we know the entire side length of the square now. We know it's going to be square root of 10. So that's good. So now let's move on, because this is not going to do us a lot of good unless we do something. Remember, we're trying to find the rectangle area, so we want some way of doing this. And so a natural choice of what we're going to do next is we're going to draw a box here, because when you're like bored, this is just like the right thing to do. In reality, the idea is that half of this information is no longer relevant to us. Like, it doesn't really matter that this is a square anymore. We really just care about the neighboring area around the rectangle, and we have a lot of measurements to help us. It really doesn't. We don't care about the other stuff going on, so we can block out like distractions and just focus on what we need to do. And that's this rectangle here. So we're gonna try to find some side lengths here, because that's good. So we have that this is 1 over root 10, remember? And because of Pythagorean theorem, this is going to be 3 over root 10. And we can label in a bunch of these. It's going to help us with finding the dimensions of this rectangle. 3 over root 10. We have 3 over root 10 here. 9 over root 10 here. Can you read any of this? No, you can't. And then we have 1 over root 10 here. Oh, what the fuck? 1 over root 10 here. Okay, so that's good. And now what we have is that this here, you see this? Well, because we know the whole side length of the square is root 10 or 10 over root 10. So then the missing part here is going to be 7 over root 10. And similarly, we have, if we draw here, we know this is 3 over root 10. Wait, no, this is 6 over 6. This is 6 over root 10. Okay, so see, I'm really good at this, so you should definitely be watching me solve this problem, because I definitely solved this problem during the contest. I'm qualified at this. So this is 6 over root 10 because we also have a 1 over root 10 here. So yeah, we have a 6 over root 10 by 7 over root 10. So that's helpful, but not really, because we still have some points of interest, like literally points of interest. So we also know that this here is 3 over root 10. Because of all these triangles are congruent once again. A lot of this stuff is all powered by congruent triangles. And finally, we also know that since the bottom is 6 over root 10 here, 6 over root 10 here, this triangle here, you see this triangle here? It's actually similar to this one. All these triangles are similar. It's really good about this problem. Everything's similar. And so this is the 6 over root 10. This side length must be 1/3 of that, so it's going to be 2 over root 10. And then for this remaining one, since we already have a 3 over root 10 and 2 over root 10, and it has to add up to 7 over root 10. So this missing side length, it's going to be 2 over root 10. Okay, so now now we don't have to worry about anything else. We can just look at this rectangle now. So once again, the side length's 2 over root 10, 2 over root 10, 3 over root 10. That looked like a 16. Oh, shit. Now it looks like an 8. Okay, well, let's erase this. I'm doing this on first take, so it's gonna be crap, but okay. And then, I don't know why I wrote 3 here. It's a 6. Okay, panicking now. Sorry, momentary delay. This is 3 over root 10. This is 6 over root 10. And then this is a whole thing 7 over root 10. So we haven't marked some of these because we don't know what like this is yet. Because for once this triangle is not similar. Like this triangle is not similar to anything we've had so far. So we have to figure out what this is. So when we don't know what something is, we call it X. So we're gonna call this X. So then we actually do have some similar triangles though. This triangle here, so this triangle here, is similar to that one. So we can use some side length ratio. So first of all, we know this side length is going to be equal to 6 over root 10 minus x, because it just is. And then because of similar triangles, we're going to have that this is, wait for it, x times 6 over root 10. Oh wait, no, shoot. Minus x all over 3 over root 10. That's awful. So we're gonna hope that like some stuff cancels out, because this is not nice. And then we're not gonna do. Okay, so this is the last of dirty stuff. So we're gonna draw this line here, because this triangle here, recall this triangle, yeah, and it's actually gonna be congruent to this one because it just is. So then that means that this is 3 over root 10, and this is x. And this triangle is actually similar to, you can see here, it's this triangle. It's similar to this one. Wait, no, not this one. This one. This triangle here. See this triangle here? Okay, this is such a mess, this diagram. But this triangle here is similar to this one, which means that it's in a 1:3 ratio, which means this is x over 3. Okay, so depending on how much of this you can read, we can now proceed with some stuff, because we know that this side length here is equal to this side length here, so we can add up each side length and get an equation. It's a messy equation with a lot of over root 10s in it. So we have 7 over root 10 is equal to x times 6 over root 10 minus x over over 3 over root 10. It's gonna take a long time to draw it by mouse. I need to get a stylus. Add 3 over root 10. Add x over 3. And despite all the complicatedness, this is just a quadratic. So we're going to simplify this. And you can go through the algebra, but it's going to take me forever with a mouse to write this all out. So I'm just going to write out the quadratic that we get. And this quadratic is, wait, I can't find my mouse. Okay, x squared root 10. That was this awful square root. X squared root 10 minus 7x. Add 12 over root 10 is equal to 0. You just have to trust me on this because I definitely did the math correct. I probably did this wrong. And now we have that x by the quadratic formula is equal to plus minus, wait, no, that's not how the quadratic formula goes. I don't remember the quadratic formula. 7 plus minus square root of 49 minus 48. It's kind of nice that we don't have a root 10 in the square root anymore, because the square root 10 here, it's canceled by the over square root 10 here in the 4ac part. And then that's all over 2 root 10. And we can rewrite this nicer. It's actually not so scary. X is just either 4 over root 10 or 3 over root 10. That's really nice for such an ugly quadratic initially. And so we can go back up, and to go all the way back up to our original diagram. And now we have that this side length here is either 4 over root 10 or 3 over root 10. Wait. And so then we have that this this is 3 over root 10. And that was just original. This is not an equation because we already have it from here. I'm just not working on this one because this diagram is too complicated. So we have this is 3 over root 10. And then that means that this hypotenuse is 3 over this hypotenuse. If we have this, if x is 3 over root 10, then the hypotenuse is going to be 3 over root 5. And if x is 3 over root 10, we can see down here that this is also going to be 3 root 10. And so is this. And r is actually going to be a square if x is 3 over root 10. So we have a 3 over... This is not legible. So the area of r, one of the possible areas of r is 9 over 5, because we have 3 over root 5 squared. And then the other possibility is if x is 4 over root 10. So if we have 4 over root 10, this is also pretty nice, because we have a 3, 4, 5 triangle. So instead of this stuff, we're going to get rid of this. It doesn't exist. Okay. Instead of this, we have 5 over root 10 here. And then this is going to be 2 over root 10. And then by some other stuff, this is going to be a 3, 4, 5 triangle again. So this is the 3 side, which means that this segment here is going to be 5/3 as long as 2 over root 10. And that is 10/3 over root 10. That's compound fraction, which is kind of nasty, but that's okay, because we're almost done. And so the area of a 5 over root 10 triangle, rectangle by a 10 over 3 over root 10 rectangle is going to be a 50 over 3 over 10 rectangle. So a 50 over 3 over 10. And this is just 5 over 3. So it asks for the sum of these possible areas. So we have 9 over 5. Add 5 over 3. And that's equal to 15, 27, add 45 over 15. Did I mess up? Yeah, I messed up. What did I mess up on? This is 25. Yeah, so I'm really good at this once again, just to remind you. I know what I'm doing. This is just, I'm just going easy on myself, because I know, if I get everything right, I'm gonna, like, be overpowered. So this is gonna be, once again, I don't know how to add. This is gonna be 52 over 15. And the question asks for m at n. So we have, I can't find the mouse pointer. Okay, 52, add 15 is, 67. And we're done. Yay. Okay, bye.